Good morning, everyone.
Hey, good morning, Mr.
Good morning.
It's my pleasure hosting you today. Maybe it's early in some countries, and the others it's before midday. Um, I hope that everyone's gonna. Anyone have any question? Please just put it in on the comments, and I'll be covering it. And on the other side, this session is uh, not oriented to a single software, but also will be highlighting a general technology. So please feel free to ask any questions related to digital twin, reality modeling, or even context capture software, which is going to be under focus. I think now my screen is clear. Please mute your microphone just to make sure that there is no echo or noise. So briefly about Geomatics, we are a system integrator focused on geointelligence. We provide our customers with full-fledged array of applications focusing on different sectors, or maybe various sectors like oil and gas, urban planning, and also we do cover surveying as a main core. But this, and because surveying already serve many sectors, or maybe all engineering disciplines, this makes geomatics and through reality modeling an optimum solution for digitization and upgrading capabilities for different sectors. So about ContextCapture is a software provided from Bentley Systems, the leading digital engineering provider. ContextCapture is a photogrammetry-based software, which based on pixel recognition in multiple photos, in which it could generate a 3D model. So you can see the object from different perspectives, and then the error triangulation is done by the software, and also the reconstruction of the model itself. And at the end, you could see a 3D model and reality modeling of what you are studying. So I just share now an example for us to for those who didn't saw a reality model before, to be with us on the same frequency. This is a reality model for a substation. It's done using different methodologies, from ground imaging through a camera, and also aerial photogrammetry through an unmanned air vehicle. You could see some details which could be very shocking for some of us, that you could get details you could even read this plate with all information. Why is this necessary for many businesses? Because this could save you from going to the site, could save time, could save money, and also many stakeholders could share their thoughts and their decisions over the model. If there is an emergency, maybe the guy from the field would raise the problem, or maybe the sensor, which is already installed on this pump or on this cooling unit will raise an alarm, and then another engineer from the office would be able to see what about how to solve this problem, and he might realize that maybe one of the components need to be changed, and he can identify what is which vendor would be able to help if this part is in stock or whatever. So the problem could be solved in minutes before it's more complicated. Another example from oil and gas industry. We could see this complete refinery or distillation facility modeled in one mouse click in front of the user. So we could do some calculations for any volumetric calculation we may need, any distance measurements we may need. It could be done in seconds. I just pressed here on this icon for measurements. In less than 20 seconds, I'll be having an accurate coordination for the whole site. I could press now in any point, maybe this elbow here. I will get very accurate easting and northing and mean T level. And this is 100% surveying solution, which means that I could switch between different special reference systems, and I could still get the accuracy in my local coordinate system. We could do some volumetric calculation to see if we need to add another tank here, and to see if the area is okay, and if the cotton and fill volumes are within the standards for the alignment we need. So in general, this application allows us to model whatever we need at different levels of size and accuracy. So this is a perspective behind the concept itself, and also we could add more accuracy, because the acquisition is one of the most important, or maybe it's the key for a successful reality modeling project, and also key for a successful processing. So now when we import the images, maybe if they are not acquired in a correct algorithm or pattern, the software would not be able to use its artificial intelligence to do the error triangulation and the reconstruction. We could use photos, maybe mounted on a camera or in my hand. You know, one of the common mistakes that reality modeling or this technology is just plugged into drones or into aerial platforms, because you can use your normal camera or even your laser scanner, because we still have a hybrid mode in which you can merge both accuracies from spatial accuracy from the imaging and the point cloud accuracy from the laser scanner. But you still could use ground tools to acquire a very, very accurate and maybe more accurate model than from an aerial perspective. Also, you still could use different data sources according to the technology you already have or you are using, or to the workflow which is already adopted in your organization, starting from mobile mapping systems, passing by large oblique cameras for manned airborne vehicles like Ultracam, like Leica, like Trimble, like different companies who are providing those giant cameras to model cities, passing by Regal, in which you could get the most accurate LiDAR data on the planet. And then you could go to simple Phantom 4 or Phantom 4 Pro drone, which could cost you less than $1,800, and you could still get a very, very accurate 3D model, but you still to do some ground control points. Or if you're lucky to get the real-time kinematic version of this drone, you will be doing a very good job with a very limited budget project. So we can see mobile mapping systems, we can see fixed wings with belly landing, we can see some cameras flying in the air via some dedicated drones. So sky's is the limit. The Bentley and ContextCapture, especially after increasing the limit of the point cloud via, into a single project for the desktop version into 3 billion points, are now unlimiting any capabilities for the teams working with the software to be able to import their data and to put it all in one source and then get the different accuracies according to their needs. Some examples and best practices for acquisition, because this is maybe from my perspective, this is a technology. This is a barrier about this technology. This is a problem which makes people not very confident about using reality modeling or using photogrammetry softwares. It's the acquisition. So, okay, the software is very smart. It can do everything for me, but how can I get the data set accurate enough to be able to get those results? So those acquisition techniques vary from application to the other. They vary according to the level of detail I need, the nature of the object itself, the orientation itself, the accessibility. So, but as a concept, we should focus on the overlap. So here, from my perspective, I did overlap because I'm taking so much images, but the overlap depend on the focal length of the camera, which means that the coverage maybe here is not allowing me to do any kind of overlap. Those are just some single photos. But here, when I decreased the space between different photos, and I successfully got an overlap. Maybe this overlap is just theoretical example, but it's not enough because we should get more than 60 to 80% to be able to do reality model. Of course, less overlap we could still use for some application like also photo or producing 2D maps, but we are here to speak about 3D reality model. Same example here. So there are some constraints, and we are here to discuss the technology, not the software itself. Maybe this is one of the most capable softwares in the world among users, but again, there is technology limitations in the photogrammetry itself, which means that any shiny and transparent and reflective surfaces would hinder me from doing my job. We need to use different tricks. So with the glass and the mirrors, we could use filters with the camera. And also for areas in which there is not too much objects for me to do the reconstruction, we could use more ground control points. So in a poor texture or no textured surfaces, I would face some difficulties, but still have some tricks to be solved. Here, as an example, we can see this river for this spaces now in the update, I think in update 15 in ContextCapture, was solved with that the software automatically recognized the problem and it could fill this surface. So now you started to have help from the development team to solve your common pitfalls or the technology pitfalls. But again, from during the acquisition, if you didn't take care and if you didn't know those limitations, you will not be able to mitigate those limitations in the office. So you should be aware about those limitations, and then you could be able to solve them. You can import import images from any camera, and you can import LiDAR data or point cloud data from any laser scanner or LiDAR system. So it's up to you, starting from your mobile, professional camera, drone, or even airborne camera system. So we are here speaking about overlap from between 80 and 60%. And this overlap should not only be a forward lap, it also should be a side lap, because you don't want to see your model from a side perspective. You need to see it in a 3D mode. So all the four faces of any cube should be very similar in accuracy. In this case, you should save a consistent overlap and side lap from 60 to 80%. And again, you need to do the calculations according to your camera resolution, according to your lens used, and of course, this will impact the height you will be using in case of aerial photogrammetry, and in case of close range photogrammetry, this will be impacting the distance you are using. As an example. And when we speak about at least 70%, we are speaking about maintaining 60 to 80%. Also, one of the most interesting points to be covered in this session is the consistency of the imaging. So if you are taking image from different angles or from different depth, which means different height or different distance from your perspective, try to make them consistent. And if you are taking too close images like this and too far images, please make sure that you do another round which enables the software to connect between this data set and this data set. And also, if you are having images from different perspectives, which means that I'm using my mobile camera or my normal camera or my professional camera from the ground, and then I decided to take an oblique imagery or a nadir imagery from the top with my drone, please make sure to have another run to be able to fuse this plane with this plane together through this overlapping oblique imagery. So in this case, you are helping the software to match pictures together and also to keep the consistency and to keep the accuracy of the model itself. Here you can use your mobile phone camera to take images. So maybe the overlapping angles, to get an overlapping pictures, you shouldn't use angles more than 15 degrees to be able to generate a nice model. So now when we are speaking about drones, there are a lot of models, you know, from the very simple Phantom, DJI Phantom 4 drones, passing by those Sony cameras mounted on Falcon Falcon drone, sorry. And on the other side, you could also use a fixed wing. Maybe it's now using nadir only, but very, very, very soon we will be seeing combined nadir and oblique cameras on those fixed wings and on normal and on normal quadcopters. So you will be able to take both nadir and oblique photogrammetry in the same flight line, which will save a lot of time. So because you need to take images with different angles to be able to get a better reality model. So you need to fly many times. So I'll be flying, if I have one camera and one lens on the drone, I'll be flying with nadir and then 30 degrees to the right and then 30 degrees to the left and to the front and to the back. So I need to fly 5 times. Or if I have those 5 cameras mounted on those 5 directions on the drone, I will be very happy because I'm gonna fly once. I'll be sharing, for surveying, we are always connected to technology, and technology never stop developing every day. So I was sharing this to show you those new oblique cameras we are just speaking about. This is a company from China. They were working on their product for very, very extensive R&D exercise. Maybe I was monitoring them through the past 2 years, and now they started to have a well-tested and calibrated product. Now you could mount this camera over your drone. They have different models which could be mounted to different drones, and you don't have to fly the 5 times. You could only fly once. And then here's your Nadir data set, and here come the other 4 data sets for the oblique photography. And you will be able to get, per single point, you will be able to get 201 megapixels of data, which means that you will get 5 images with the total of 201 megapixels camera. Of course, every one of them is kind of it's around 40 megapixels. But again, the amount of data which will be captured from one perspective is huge, which will save you time, and again will result in a longer processing time and a very accurate model. And here is the point in which you could rely on ContextCapture. Other solutions maybe is not very clever on such big data sets and big scale projects, and we will see this later. They still have accessories in which you could mount the camera on different platforms, and they also updated their solution to be compatible with the new Matrice 300 workhorse. Another introduction, it was introduced maybe since 18 months and is very, very effectively spreading over surveying markets, is Phantom 4 RTK. It's a normal DJI and classical model of Phantom, but again, it's very, very unique because it's got a real-time kinematic dual channel sensor installed on top of it, and it comes, if you bought the combo, it comes with a surveying grade global navigation satellite systems base station, in which you could use to get live corrections or maybe post-processed corrections to your imagery, and then you can process directly with 2 to 5 centimeters accuracy. Always for us not to get bluffed with data coming from different marketing materials from vendors. When we speak about 1 centimeter, he means plus or minus 1 centimeter, which means 2 centimeters. And again, in the vertical accuracy, it's always less than the horizontal accuracy. So when you're, and also you should ask yourself, okay, this is now about the GPS accuracy. What about the geospatial, the spatial accuracy of the camera itself I'm using? Because according to different heights, you will be able to get different image qualities and ground sampling distance. So again, you should focus on how many meters are you flying, and this will be impacting your ground sampling distance. And then you can combine with the data coming from your GPS, and then you will have an absolute horizontal or vertical accuracy. We speak here about a ground station RTK application, which is mounted on your remote controller screen. You don't have to get any software from third party to do your flight planning. You have very long range, you have your base station, you have a complete solution in which you could generate very, very nice models with very cheap. It's less than $10,000 with all the accessories needed and all the batteries which make you fly for 2 or 3 hours. The sensor itself is mechanical shutter, not a global one, which means that you will get better calibrated images with less spherical errors. And it's built for surveyors, but anyone can use it. This is the point here, that the technology is not only limited for experts now. Even you as an engineer, or even if you're not an engineer from any other sector, you could easily make use of the technology evolution by using such platform, easy to fly, and this and also a very clever software like ContextCapture to change the way you are working in your industry. One of the other companies which is really interesting when it comes to R&D, Quantum Systems. They are a German UAV maker. They have different models, but let's speak about their surveying models. They have the Trinity F9. This platform could fly for 90 minutes with a Sony RX1 camera with 42 megapixels. It could produce you a stunning, maybe more than 5 or 6 square kilometers per flight, with very, 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 very good accuracy and very good ground sampling distance. We still have also the LiDAR option through the Tron. The Tron is a more rugged platform in which you can mount any sensor you need, because it could take up to 2 kilometers. So you can add your Sony camera, you could add your phase 1 camera, you could still add your LiDAR system. They have integration with YellowScan. So you have here a Planck system, you have Velodyne system, and you have the drone, and with the software, everything in one package. So sky's your limit when you want to go for a project with high accuracy LiDAR data. You can see the vertical takeoff. It's a fixed wing, but it can take off vertically, and it still can get back to its takeoff location vertically, which save time. You don't have to go to the airport to put it on the track. It saves the equipment itself, saves the calibration, because no need for catapults, and also no need for using your hand throwing the drone, because it may one day you may fail. Okay, and also in the other side, it doesn't use any parachute, it doesn't use any belly landing. It lands safely with your sensor and your data. One of the interesting points that here we have to use only one base station, but sometimes we need to check, because we are using RTK and PPK technologies, of course, but sometimes we need to check ourselves. We need to know, are we still getting the same accuracies we are expecting, or there's something wrong. So I need to take some ground ground control points to check about my accuracy and to get better feel of what is the project going there. We have a very, very nice solution from Planck and Trimble. It's the smart base, the smart target. Those smart targets, you don't have to do anything. You just throw them in the field. They have a GNSS dual channel. They start to log data, and they will be already recognized during processing through a plugin, and you are good. You don't have to put the target, and then you need to make some changes in your workflow to get the accurate coordinates of those targets to be imported as a ground control point to your model. So it's just done directly. And of course, for laser scanning, if you need to use a laser scanner, the rest is because now we covered LiDAR and photogrammetry. So also laser scanning, one of the nice examples is ZNF. They are leading in their industry. This laser scanner, the 5016, also is a fully autonomous, versatile platform in which there is no need for registration. There is an IMU and there is automatic registration process, so you can mount your system on the tripod, and you will be getting direct registration with the previous station through the Blue Workflow technology, in which you can use one scanner or two scanners on the same project, on the same tablet, and you could run in the field, and you don't have to do any kind of ground network, and you don't have to get any GPS with you if you are having already a georeferenced ground control point previously available. You don't have to do it again in the field. You will get 100% registered point cloud. Let's get back to our presentation. So now we had a glance about some technologies we might use. What are the technology updates? How can I do my photogrammetry job or my surveying job with less effort and with high accuracy? For some platforms which doesn't have any planning software like the Phantom 4 RTK, you might be able to use any third-party application like Drone Harmony, like Drone Deploy, like ContextCapture, like maybe DJI Terra. So you will be able to do that in a very, very, very accurate manner because it's going to be done autonomously. And also, if you don't have any experience in flying drones, feel safe to fly your drone through one of those softwares. Of course, you should take care of the battery level, you should take care of the wind, you should take care of other aspects about there is no animals around you, there is no kids, you are controlling the area you are taking off and getting back, and also there is no high trees in your flight path or buildings, but you still could do the job if you are not 100% capable to fly a drone. You can still do the job by some training. So those softwares enable you to use the technology. Some tricks, if you want to take a reality model, please don't get very, very close and get also the maybe more than 50% or 40% of the image is gonna be a sky. Try to use an angle in which you are getting some features to add texture to your image. And for data acquisition best practices, as we mentioned before, that we need to take images from different angles if we are interested in a point of interest which will be mapped. So we took three circular overlapping rounds, and then we are doing an intersecting grid to be able to cover both nadir and oblique perspectives for all objects, and at the end I'll be able to get a very accurate model. This is an example. So we took a nadir imagery and then we took some manual photos here, because if this shape is not regular, so you will not be able to use as a circular workflow. It's always depend on the object itself, and it depends on your experience and your decision in the field to be able to get a very nice model at the end. Here we have a bridge, so you need to cover the bridge from downwards, and you could use your own professional camera, and you can use the stairs to get the perspective from high. So it differs, you know. This is an example to show you how could we use images to generate the model. And here, if you are on a city scale mapping, it's much more preferable to use those merged nadir and oblique cameras. Personally, I'm waiting them for maybe more than 3 years to be available on UAVs, because this will impact the industry of city modeling heavily, because to be able to cover large areas, you will not have the option to fly twice or 3 times or maybe 5 times to get nadir and 4 oblique data sets. But if you can get it once, it will be very very good. I'd like to share some models. So we could get more near to different applications. This is a very interesting 3D model for a valley. You can see details. So here you can use this application maybe for mining, maybe for excavation for monuments, maybe to extend or to establish a power grid network. Is another example for mining. You could get very accurate data sets. You can even recognize the footprint of the tires. And easily you could make any volumetric calculation for any pile. For example, this one, you could just do this. And you could get the volume of this pile to be able to plan for your number of trucks which need to come to cover for you to remove those products from the ground. And also you could plan for your mine, for the whole road, and also artificial intelligence now could get you many valuable data for such application, like those brick lines, like before using explosives in this area, we need to do calculation, and after the using the explosives, we need to do the calculation to see how many ore do we need to remove and how many trucks do I need tomorrow to be able to contact my contractors. So it's very important to use such technology. One of the most interesting applications is city modeling. And here we can see this main part of Philadelphia modeled on, I have an old computer. This is a 3 years old outdated computer. It's not the most powerful one. Now you have a 3D reality model for the whole city with very good resolutions. Municipalities and facility owners and maybe different authorities and ministries could use such data very effectively, because this give you control over the city. You know, you can easily plan for any kind of maintenance. You can recognize the cracks which is available, and you can merge, of course, with mobile mapping data to get more accurate data from the ground. You could monitor the progress of on any project. You know, now you can see this project under construction. This is a newly developed area, and this building maybe is about to finish. So you could still monitor the development, monitor the safety concerns. You can monitor the urban planning consistency with the other buildings. So sky is the limit when you are thinking about the applications of such technology. And for city modeling, maybe I still have 10 minutes before we start to reply questions. I'll be sharing another example of how can we use reality model in different applications. So those slides will speak about smart cities. to be able to have a smart city, you should have very it's not connected with the buildings and the facilities. You're not going to make the out use of it, the maximum use of it. Also for energy networks, water, renewable energy, or storm, rain, emergency networks. Also, you still get them connected to each other, or you will start getting problems like this. Someone who is doing any maintenance in any network, he could easily hit the other one to make a problem like this. Also, this will generate a flood. And on the other side, if you don't have, you're not connected, and you still have a storm, network capability to compensate this water, but they are not integrated together. They will not. Your heavily invested asset will not be used on time. So you still have a lot of question mark when you have a disconnected infrastructure. But when you have a connected infrastructure, you will be able to integrate all those networks together, and you will be able to use them over the reality model. How can we use that? Small example here that maybe we could take a glance about Bentley Solutions here, because we are speaking about one of the most, maybe the biggest technology provider for digital engineering and infrastructure solutions for different sectors. You speak about mining, water and wastewater. You speak about city development, nuclear power, bridges, power plants, process plants, wind farms, rail and road construction, utilities. We have playbooks of softwares which could cover all engineering direction, and all those solutions are based on MicroStation, the first CAD in the world, and also using project-wise and asset-wise, you could still have a consistent workflow over a connected data environment, in which you could make sure that your project is designed respecting BIM standards, and during construction and during planning, you will be able to use existing reality models, not to get disconnected, the office disconnected from the field. So you'll start to get problems when you go to the field and start implementation. And after having your assets built, you will be able to manage it through performance management, monitoring capabilities, and also maintenance and asset integrity management tools. The data we are all using, maybe it falls on those four directions: transportation, road or rail or bridge; energy, whatever the source is and the tools used to use it or to generate it; and water, which is one of the most important infrastructure components in any city, and those buildings, our homes, ministries, airports, municipalities, and everything. So this data is already designed and already maintained through different technologies. we cannot depend on a single source. So some of us use Israel, the others use Bentley. Maybe a lot of users prefer Autodesk for their CAD drawing. When you are respecting new OGC and open platform standards, you should also you should also respect IFC, in which different engineering technology data sources could be found in any complex solution. We could put all of them on our reality mesh. So all this data from different sources will be overlaid on the city model, which is a reality model, 3D accurate model, J-coordinated, and then you can do a lot of things. Also, you could use data coming from any operational technology sensors like SCADA, like IoT, like a simple flow meter in your facility, or a simple temperature sensor, which could tell you that the temperature is going very high now. And you can use any IT infrastructure to run all this environment. And at the end, you will be able to connect with any ERP, and you could see the results on any Bentley application or even any third-party application. So you don't have to use Bentley data from the beginning, and you don't have to use a Bentley platform at the end. You still could use all those data sources on a reality model. We will see now an example, and at the end you will be having a virtual city. So to plan this bridge, you can easily do reality model for the area itself, and you will start doing conceptual design over the existing conditions. Also for this metro project, it's always very difficult. Excuse me. It's always very different to plan metro station and a metro project or a rail underground project in an existing city, because you are now challenging all the infrastructures which is already have been built over decades. But with reality modeling, you can plan this easily, because you could put your CAD drawings over the existing as-built drawings, and also you can respect different other aspects which will ensure your success at the end. So we can use this technology during planning, design, construction, and operation. Also, every data source, so now maybe the energy or the Ministry of Electricity is using Small World from GE, and they are using Bentley. People from the GIS in the municipality are using Esri, and one of the building developers is using Autodesk or Bentley or maybe IFC. So how can we put data all together? We could keep the data sources and their destination, because every data owner don't want to share his data to the other parties, but we could study a specific area, and we could access a specific layer of data after permitting this user to access this data temporarily. And at the end, we can deploy everything on the reality mesh. And of course, we can use this in Bentley environment and also in third-party environment. Now we have our reality model overlaid with information and data, and we can do a different level of GIS analysis. You know, before closing this whole of the maintenance project, you could make a reality model using a mobile phone, and you can attach this file to this area with a timestamp, and then after maybe 5 or 10 years, you can come back and open this model to see what was done before and what was the condition of the other infrastructure. And you don't have to do this anymore to start to planning from the above the ground, because you will have a full underground perspective with a footprint of every building and different infrastructures with different layers of accuracy, because maybe those red ones are not validated, but the blue ones are already validated through a ground penetrating radar or an accurate as-built modeling. Also, flood analysis, one of the very necessary, very important applications now being adopted by many cities because of the global warming and the weather changes and the various amounts of water which could hit any area. So I would love to receive some questions. Please, if
First, if you want to receive to make sure we send you the recording of this session, please make sure to register in the link that I have attached the link in the chatting box. Okay. One of our questions we have Ashish asking about Okay. Engineer Mohammed Zal, do you have a category of drones like surveying drones without remind model of drones or company?
So maybe I'm not getting the question, Muhammad. All the drones we already highlighted were surveying drones, because Phantom 4 RTK, having the RTK capability is making this drone a very, very valuable surveying tool, because you can get the direct georeferencing from the base station, or even from virtual reference station or continuous operating reference station, so you still could get the same accuracy.
Okay. Is any closed model for steel structure available?
Okay, steel structure now. Yes, we have. We have a model for steel structure. I can show. But again, maybe it's more into CAD modeling through other softwares and not ContextCapture. So ContextCapture here is to fuse, because for steel, photogrammetry is not enough, because it's first it's shiny. And according to the application you need, of course, sometimes if you just need to have the real feel, photogrammetry is okay, but steel is always, you can have thickness which is less than maybe 2 centimeters, which means that you need to get very, very, very near from the object to have a very high GSD to be able to represent those objects. And also at the end, using a simple laser scanner will be more will be more efficient. So there is another Bentley software in which you can import the point cloud, and one of them is ContextCapture also, but ContextCapture editor, which merge different features of Descartes and MicroStation. So I have a model, but it's not on this computer, and it's big. It was done for one of the big exhibition areas, and I'll be sharing it with you, Muhammad. We have another question. What 3D tower mounted cameras can we recommend? I think 3D tower mounted cameras, there are some direct solutions from Pix4D. It could be used because it's already integrated with the software, but it's very far. It's not a Bentley solution. And on the other side, if you want to mount a camera, you could get a special mount, and you can use any camera, since you have access to trigger this camera on a timely basis. So in general, you could do that, but this camera will be a fixed camera unless it's fixed on a crane. So of course, this in some areas you're not allowed to fly a drone, but again, the drone perspective is much better if you need to get results, which is enabling you to use it for reality modeling and 3D modeling construction. We have another question here. Yes, Inspire 2 with ZenMuse X5. It's going to be a perfect tool. It has only one pitfall. That's not a mechanical shutter. It's a global shutter, but still could do it because this is an over 20 megapixel sensor, and Inspire 2 is a very, very capable drone. So yes, you can use your Inspire 2. Please feel free to send me a request, and we could work something for you. Maybe we can guide you with the acquisition, and you could process your project the cloud, because ContextCapture provide mobile application processing. We provide cloud service. We provide center capabilities for huge data centers, and also desktop application. Please feel free to also share with us what do you need in our next session, because we are planning a series of sessions to cover this reach software and its capabilities. So we could dedicate a session for acquisition techniques. We could dedicate a session for the acquisition technologies itself, and also for different processing options. And we could also provide separate detailed training if needed in the case of purchasing the software. For long distance, it is a very tricky question, because what do you mean by long distance? So any drone can we use for long distance? Yes, but you will lose the accuracy, because the 1 pixel of your sensor will be seeing a larger area on the ground. So at the end, the sampling capability will decrease, and you will get a less accurate model. But of course, if you are using better lens, this will be helping you to get a more focused image, but take care of parallax. So it's like an equation. So there are already cameras now for long distance and long altitude, but those are designed for airborne platforms, and for unmanned air vehicles. We speak. My advice is not to fly over 200 or 300 meters, because this will impact your accuracy. Okay, another question here asking if we can attach a GPS on a drone and work from there. Yes, you can. There are some solutions from Cloud PPK, and we also provide those solutions. According to the model of your camera, we can integrate PPK sensor into it, but it's not the normal GPS. You should have something which is calibrated. You should calibrate the camera with a center of the antenna to be able to get the accuracy, or you will not be making use of your investment. And yes, some drones like Inspire 2 and like also Mavic and DJI, you can do this. And for other fixed wings, it's much better to buy them already equipped. But now, after the introduction of drones like Phantom 4 RTK, you don't have to do this, because you can buy it ready and calibrated from the factory, which will save you time and effort, and also accuracy. Okay, I think we already covered the questions. We would love to get feedback from your side about this session, and if you have any interest for another topics to be covered, and thank you very much.